So we're in section 2.6, our last section of the chapter. So what we're going to do, I want to talk before we jump into the stuff about the angles. I want to talk about when we prove things. Once we prove something, we call it a theorem. And a theorem is a conjecture and remember, a conjecture is just something that we think is true. A conjecture that we prove is true and to prove that it's true, we're going to use properties. We're going to use postulates. We're going to use definitions. And once we get a few of them, well, once we prove a few of them, we use other theorems. So we're going to make a logical argument using our properties, using our postulates, using if and then, the if and only if, that kind of thing. And we're going to show that something that we think is true is actually true. Once we show it using a proof, then we can use that as a theorem to help us prove other things. That's kind of how we build up what we do with geometry, is we prove a theorem, then we can use that to prove other things. Once you get past like the math that we do in school, the math that you do in the first part of college, if you're just working on science or engineering or something, you end up, you're solving problems, you're using formulas, that kind of thing. That's a very small part of math. Most of math is using theorems to figure out other theorems. We want to expand our knowledge, and that's what most of math is. So we're kind of following along with that idea. All right, so let's talk about our first thing. We've talked about this. We talked about this in chapter 1. We said that vertical angles are congruent. And we said it. We looked at a drawing. We said it kind of makes sense. But now we're going to prove that that's true. So just a reminder, vertical angles are when we have two straight lines, two straight segments crossing, and they are directly across from each other. So I'm going to label these angles 1, 2, 3, 4. So when we are talking about vertical angles, I would say angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. That's what we mean by vertical angles. Well, now we're going to make an argument, do a proof to show that this is true. So I'm going to be given. We're going to prove that angles 1 and 3 are congruent. So I'm going to be given that angle 1 and angle 3 are vertical angles. And we want to prove that angle 1 is congruent to angle 3. And we'll do our two-column proof, our statements and our reasons. So before I start writing things down, it's always a good idea when you're working with a proof to kind of think of the big picture here. So I'm interested in angle 1 and angle 3. Well, what do we know about angle 1 and 2? What kind of angles are those? They're supplementary, and we gave them a special name. They're two angles that make a line, a linear pair. 1 and 2 are a linear pair. How about 2 and 3? Aren't they the same thing? So we know, and what do we know about supplementary angles or linear pairs? What about their degrees or their measures? They add up to 180. Well, these two add up to 180, 1 and 2. 2 and 3 add up to 180. So this is kind of like what we did yesterday where we had the two segments that shared the piece in the middle. We have two pairs of angles that add up to 180 that share this angle 2 in the middle. So we're going to go about this kind of the same way that we did with that one, where we end up wanting to subtract that angle 2 away. So that's our kind of our big picture how we're going to do this proof. All right, so I'm going to start with my given. Angle 1 and angle 3 are vertical. So that's given. And I'm going to write down exactly what we just said. Measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. And for a reason for that, we said linear pair, or we said supplementary. I think either of those would be okay. All right, so here's what we're going to do. I look at this measure of angle 2 and measure of angle 3, and we know that that equals 180. And I see 180 right there, so I'm going to plug that in right there for 180. These two add up to 180, so I can plug that in. So I'm going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what property tells me I can plug something in for what it's equal to? Substitution. Plugging in is substitution. Well, now, just like we did last time, I look at this measure of angle 2 here that's on the left and the measure of angle 2 here that's on the right. I say those are the same thing. How do I get them out of that equation? We can subtract. These are just numbers, some measure of an angle, 37 degrees, something like that. So I subtract that from measure of angle 2 from both sides of the equation. I get measure of angle 1 equals the measure of angle 3. We said we were subtracting. And now I have the measures of the angles equal. I wanted to show that they were congruent. So I can just say angle 1 then is congruent to angle 3. And what would tell me that if their measures are the same, then they're congruent? Isn't that what congruent means? That their degrees are the same? We said that's how we decided if angles were congruent, if their measures were the same. So this would be the definition of congruent. That's what congruent means, that the angles have the same degree measure. And we're done, because that's what we were trying to prove. So now we know, or we've proven, that vertical angles are congruent. And we can use that, and we will use the idea of vertical angles being congruent for the rest of the year. That's one of our big ideas, big things with angles, is that vertical angles are congruent. All right, questions there? Okay, so the kind of problem now that you might see, that the book might do, what happens in geometry, especially in our book, is they turn these theorems into then ways for us to do algebra problems. So let's look at an example of that. You might see this as a homework question. That's 3x minus 10, and this is 2x plus 12, and it will say find x. So we look at this and we say, well, what kind of angles are these that are right across these cross lines? They're vertical. So what does that mean about them? They're the same, they're congruent, and when we have a situation like this, how do we write the same? 3x minus 10, how do we write the same? Equals 2x plus 12. Equals means the same. And now we just have an algebra problem. Subtract 2x from both sides. Once, and unless the problem tells you justify your steps or that kind of thing, you can just do the algebra. We don't have to give all of our reasons. So I get x minus 10 equals 12. Add 10 to both sides, and x equals 22. And if the problem then asks us to find the measure of the angles, we'd plug 22 in here for the measures of the angles. And if you weren't sure you did the problem right, you could plug x in and make sure that both of those were equal. I think we're pretty good here. All right, questions on that problem? All right, what I want to do next is we're going to talk about a couple of other theorems that are very similar to the first theorem that we talked about, that have to do with congruent angles. So the first one, the congruent complement slash supplement theorem. And I wrote complement slash supplement because we'll do the proof for the complement part. The supplement part is exactly the same, you just change a number. So this theorem says angles complementary, I'm going to say slash supplementary, to the same angle are congruent. So let's draw a picture of what we're talking about here. So I have this angle 1, and I'm just going to talk about the complement part for now. I'm going to call this 1, 2, and 3. And we're going to be given that angle 1 and angle 2 are complementary. We'll do the complementary part. And angle 2 and angle 3 are complementary. We want to prove that angle 1 congruent to angle 3. So we'll do our 2-column proof. Now before we do our proof, let's talk about how we're going to proceed here. If angle 1 and angle 2 are complementary, what does that mean about them? What does complementary mean? They add up to 90. And angle 2 and angle 3 are complementary, so what does that mean about those two? They also add up to 90. So we have two things that add up to 90, and they share that angle 2. So I have two things that are adding up to the same number, but they share that angle 2 kind of in the middle. Well, this is really exactly like what we just did last time and what we did the time before with the segments. What we're going to do is set the things up so that we can subtract away that angle 2. And then we just have something that has to do with angle 1 and angle 3. So really it's the same idea that we've already used. So let's I'm not going to rewrite the givens. So I'm going to do this. I'm going to circle this, and I'm just going to draw an arrow, because we don't need to rewrite all that stuff. That is given. So we know that's true. Well, let's write down what we just said. We're going to say the measure of angle 1 plus the measure of angle 2 equals 90. And the measure of angle 2 plus the measure of angle 3 is 90. And our reason there, isn't that what complementary means? That they add up to 90 degrees? Yeah. That's going to be the definition of complementary. Complementary means their measures add up to 90 degrees. Well, this looks exactly like what we just did. Here's something that is 90, equals 90, and there is a 90. So I'm going to plug that in there. And I'm going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what tells me I can plug something in for something that it's the same as? Substitution. And just like before, I see that I have a measure of angle 2 here and a measure of angle 2, and I want to get rid of that from both sides of the equation. So I'm going to say the measure of angle 1 equals the measure of angle 3, because I subtracted that from both sides of the equation. And now we know the angles' measures are the same, so we can say they're congruent. And that is the definition, I'm just going to write def, of congruent. That's what congruent means, that their measures, their degrees, are the same. So now we know that when two angles are complementary to the same angle, that they're congruent. And I think in the homework, either today or tomorrow, it will ask you to prove or to fill in the blanks for the proof for the congruent supplements theorem. It is exactly the same, except these two 90s would be 180, because supplementary means they add up to 180. So that's why I wrote complementary / supplementary, because it's really the same thing. Complementary, this number is 90, because the angles add up to 90. Supplementary, that number is 180, because it's supplementary means they add up to 180. So we really kind of did two proofs in one. And this proof is almost exactly like the last proof we did. So that, and it's almost exactly like the proof we did the other day with the segments. So we kind of did three proofs. And you'll see that happen as you do proofs, is they kind of follow a similar pattern. All right, questions there? Okay. I want to talk about a couple of other theorems that are kind of like those, but they're really easy to figure out. The first one. All right angles are What are you going to guess we're going to say about right angles? They're 90 degrees and how are they related to each other? If I know that one angle is 90 degrees and another angle is 90 degrees, what can I say about them? They're congruent. All right angles are congruent. So this comes up a lot of times when we're doing proofs that have to do with right triangles, because we're comparing two right angles. So we're saying angle 1 and angle 2 are right angles. So angle 1 is congruent to angle 2. And we just talked through how we would prove this. We would say angle 1 equals, measure of angle 1 is 90, measure of angle 2 equals 90, measure of angle 1 equals measure of angle 2, so they're congruent. All right, and the last one. Angles that are congruent and supplementary. Are, and let's think about that for a second. They're congruent, they're the same, and they're supplementary. Well, supplementary means they add up to 180. So if their two angles are the same and they add up to 180, what do they have to be? Well, what does each one have to be? If each one is the same and they add up to 180 degrees, what does each one have to be? 90. So we're going to say angles that are congruent and supplementary are right angles. So that's another theorem now that we can use when we have things to do with angles. So in symbols, we'd say angle 1 is congruent to angle 2, and angle 1 and angle 2 are supplementary. Measure of angle 1 equals the measure of angle 2 equals 90 degrees. All right, and we just talked through how we would go about proving this. All right, questions? Okay. So I'll answer questions about homework and algebra review. Then we're going to work on our quiz correction work, and then we'll have some time to work on our homework. So is page 124, number 7 through 13.